Hi and welcome to this new video. In today's video we are going to analyze the company QpiAI, which is a company in the space of quantum computing technology, and we are already at their website. It says vertically integrated AI and quantum computing. So let's figure out what they are actually doing. Here it says solve complex scientific and business problems in life sciences, energy, material, finance, logistics, automotive, manufacturing, and sustainability. So sounds very much like a computing company to me that is using computing technologies, so AI and quantum, to solve those algorithmically complex problems mentioned here. In the background, we see a cryostat with some radio frequency lines, which looks very much like a, for example, supercomputing quantum computer. Superconducting quantum computer. Sorry for that. Let's see. They say discover QpiAI products and quantum and AI solutions. Before we click on that, let's go a little bit down and try to understand a little bit better what they are actually doing and what their services are about. So it says advancing intelligence, modeling and intelligence compute. So as we see, it's not only about the compute itself, it's also about the modeling that's going along with it. So here we see our integrated approach combines modeling, compute, and automation to solve complex business and scientific problems at utility scale. So we see there are different offerings here where you can discover more. Very typically, we see three different ones. We see enterprise Gen AI solutions, quantum-enabled solutions, and full-stack vertical integration. So this one is very much focusing on the AI part. So you can see also here we have the typical things that AI technology brings along. So predictive analytics, compute vision, large language models, and AI agents. Then we have quantum-enabled solutions, so computational problems and optimization, simulation, and machine learning to drive industries across scientific, discovery, finance, healthcare, or manufacturing. And then we have the full-stack vertical integration, which is quantum computing seamless into AI stack. So this is combining both the quantum and the AI offerings that they have. Now scrolling down a little bit further, we see the full stack quantum computing. So here we see a quantum computing system. It says QpiAI Gen 125 quantum bits quantum system or qubits quantum system. So we see here that looks very much like a full system. So we see here the cryostat unit. Here is the vacuum connection up here. This is looking like a control rack with probably also like the tank in it for the dilution refrigeration system. Then here we have a scheme of the whole vacuum lines and pumps and so on. So that looks very much like a system that you can buy from those cryostat companies. And then inside we have these different stages here. So we can already see there are like different stacks, which will probably inside you have the different temperature stages. So what does it say here? It says single and multi QPU. So QPU is quantum processing unit, integrated quantum computing system with a unique QPU virtualization capability. Not sure what the virtualization capability actually refers to, but probably we will figure out more in a second. Combining the strength of quantum and AI technology, empowering enterprises to solve complex computational problems, seamless integration with existing high-performance compute systems. So basically the idea is that you can integrate this system into your existing supercomputing infrastructure. Probably you can run the AI part on your supercomputing system, and you will have this quantum computing system as an extra system, which you can then combine both with each other. Another important note here, it says quantum computer scalable up to 300 qubits. So Gen 125 qubits says you can go up to 300 qubits. As I already assumed before, it's superconducting qubits. With that comes along the typical properties of those. Then we see here enterprise-ready quantum computing, so AI to quantum, full-stack solution, application optimized, QCAS, so on-demand quantum resource with hybrid quantum classical capabilities, allow business to scale without heavy infrastructure investment, and then quantum cloud, so basically you can also use cloud-based quantum computing with them. Scrolling down, what we see, explore quantum and AI products. So here now we can see what are the actual products, and ooh, that looks actually quite nice. So there is a very nice interface here where you can basically by drag and drop build your own algorithms. You see down here the block sphere, which is a visualization of a qubit system. Then you see here basically your qubits 0, 1, 2, 3, and then you have here the different gates that your system can actually operate. You can then drag and drop those and then perform single qubit gates, and probably there's also somewhere multiple qubit gates. And then you can see here, I will zoom in quickly, it says it runs on OpenQASM 2.0, and it generates for you also here the code that you basically create by this drag and drop option, and you have here a create new project button. So looks like a very nice web interface to build those algorithms. And then down here you can see the histogram with the probabilities of the different solutions outcomes. So this is probably running some simulations with the OpenQASM, and then displaying them down here in this histogram. So this is the QpiAI Quantum. Then there's QpiAI Pro. Let's see what that is. That's also some interface here. Looks like this is a workspace interface, so probably something like a little bit more professional for programmers with actual programming interface, and you create projects maybe a little bit like Jupyter notebooks or something like that. It says QpiAI Pro is the most collaborative platform to invent, build, and deploy AI models in production. So it also allows for collaboration. You can work with a team on, for example, an algorithm on a notebook, probably create futuristic innovations in AI by running the platform at functionalities optimized for your enterprise data center. So 200 plus base models, deploy model on the edge data center or cloud. So here you can see you have the various different options that we talked before. So you can run it in the cloud, you can run it on the edge, so on your own system basically, without sending data out to somewhere, or in the data center, and then real-time model monitoring and observability. Then we have QpiAI Opt, so high-performance combinatorial optimization solver for business and scientific use case involving millions of decision variables and constraints. Quantum-inspired icing solver. So here we come into the quantum-inspired category. So that's basically algorithms that are inspired by how the quantum computer works, but that don't actually necessarily have to run on a quantum computer. So it uses the conceptual idea of this quantum algorithms, but it can be executed or will be executed on a classical computer. Here it says 100 times faster than traditional optimization and 10 times more scalable. Okay. And again, we see here a dashboard. It has workspaces, tokens. This token usually refers to something with an API. You have credits, so there's probably some cloud involvement. Probably you can run this also in a data center. Then there's QpiAI Matter. That's interesting. Okay. That looks a little bit like this looks a little bit like a unit cell of a crystal. So you have the different atoms that are being formed in this unit cell, and this unit cell is being repeated, and that forms at the end a crystal. So this is probably something like a material science research environment. Let's see what it says. So it says AI accelerated discovery platform for the modeling, simulation, and analysis of novel functional materials, enabling teams to design and discover application-specific materials 10 times faster. So it is a material science platform. You can see here different ideas probably of what it can be used for. So catalyst discovery, photovoltaic materials, polymer design, and high entropy alloys. It says 1,000 times speed up of DFT calculations. So DFT is also some material simulation method, which comes from physics, usually executed on high performance compute. And then it says 10 plus discovery workflows accelerated by AI. So this is basically now also using AI for material science. Then we have QpiAI Pharma. I can already imagine what this relates to. This must be something with pharmaceutical products or drug discovery probably. We can see here something that looks a little bit like a protein folding problem. So we remember there's this, what is it called? Alpha something, the protein AI from Google's AI research group, which can simulate protein foldings using artificial intelligence or some trained model, which works much more efficient than doing it numerically and, let's say, the brute force way. Let's see what it says here on the side. Quantum ready and AI-enabled workflows to run computational chemistry calculations for drug discovery on classical AI HPC, so high performance compute, and quantum computers. Hybrid quantum classical simulation models, 10 times faster drug design pipelines, and 1,000 times speed up over DFT calculations. So looks like the idea is here to have this hybrid approach. So basically, on the one hand, use a quantum computer, but on the other hand, also use a classical computer and get them to work together to solve specific problems. In this case here, material research. So you see here geometry optimization, conformer search, transition state search, and single protein energy, which are probably all very relevant problems when it comes to discovering specific drugs or developing new drugs. I'm not an expert on that, so can't say too much. And then we have here QpiAI logistics. So the good old traveling salesman problem. We can already see it here. So there's a map with different locations, and the job of the traveling salesman problem is to figure out the most intelligent route to basically reach all of those goals without losing too much time or doing too much of back and forth. So finding the optimal route between those different targets here. In the workflow, it also says route planning, fleet scheduling, network design, and supply chain simulation. So this basically is all typical stuff which is being done in logistics. Typical problems that we know from logistics. Let's see what it says here. AI and quantum-powered optimization platform for logistics, supply chain, and transportation management, capable of handling millions of decision variables and constraints. 60% distance reduction in route planning, 47% reduction in fleet size, and 72 times faster convergence time. So you see here also in all of these examples, we have numbers that they put out there as a reference. And then I guess if I click here, discover more, I will also learn a little bit more where these numbers are coming from. But before we do that, we actually scroll down a little bit further. So let's see here, industry applications in action. So transforming industries like life sciences, automotive, and finance with quantum computing and AI through advanced simulations, optimization, and predictive analytics. So basically this is pointing out the different sectors that QpiAI is working in. So pharmaceutical and life sciences, material research, manufacturing. This is probably also very similar to logistics about optimizing the shop floor. So basically the place where all of your machines are standing is limited, right? So you want to have an optimized way of getting from the initial ingredients all the way to the final product. And the way that you schedule this and also the way that you draw workforce in and so on is again an optimization problem. Then we have here logistics and supply chain, which is what we saw before. Energy and utilities is essentially also an optimization problem because you have in an energy grid, it's actually very complex, right? Because you have power plants, like you see here, this wind turbines, but you also have photovoltaic power systems. There's maybe a nuclear power plant, and all of these are producing energy. And at the same time, you have households, industrial consumers, and all types of consumers that consume energy. And the thing is, because it's electricity, it basically works in real time. It's speed of light. So you have to optimize this whole system or balance this whole system very quickly, and with all of these different systems that put stuff in and take stuff out. So it's a very complex optimization problem. Then we see here automotive and aerospace. That's very much on the material design side. We see that also here when we hover over it. Telecommunication is again probably an optimization and network topic, very similar to the energy network. And then we have banking and finance. Here we often hear portfolio optimization. We see that also here, risk assessment and financial fraud detection, which are all pattern topics, I assume. I'm also not an expert on that, so don't know for too sure. Here it says featured in, so it talks a little bit about where they have already been featured. You see a couple of big names like Harvard Business Review, VentureBeat. So actually they seem to be a quite well-represented company already. And then we see here connecting innovation across the globes, which basically tells that they are a globally active player. Finally, we see here the news section with some news from May and April. This video is being recorded end of May. So this is the latest news about Larsen and Toubro, which is basically doing a strategic partnership. Okay. Let's go all the way up again quickly and look into these things very shortly. I don't want to make it a too long video here. Quickly about the company. We are a multidisciplinary team of experts spanning AI, semiconductors, microelectronics, device physics, quantum hardware and control systems, quantum algorithms, machine learning, high-performance computing, advanced software platforms, and quantum-inspired computing. So they basically really build up everything from scratch. They have experts from all the different areas. So basically a deep tech team, and they're located in India, as we can see here on this video. Also looks like a very nice office they have. So if somebody's watching, please feel free to invite me. Would love to come visit. Then it says something here about why. Leaders in technology, full stack capabilities, enterprise first, built for impact. So yeah, already from the team, we can see they are really like full stack. If you have somebody all the way from semiconductors to building the platform and the online platform, that really means like the full vertical integration. Would be interesting to know how many people are actually working there, because it looks like a pretty big company, or like you need quite a couple of experts. Then we see here connecting innovation across continents. So they already have multiple locations, as it seems, international offices. So one is in Bengaluru in India. Then there we have Helsinki and Milpitas in California, CA. Okay. Here, leadership. So here we see the CEO, big boss, vice president of quantum. Okay, yeah. There are quite a couple of people already in there. Principal scientists, board of directors. Okay. Advisors. Okay, yeah. Interesting. And then let's see what the technology says. Okay, full stack quantum computer. Okay, so here it also explains what it means when it says full stack. So we see they do the quantum processor design, the sensor and quantum control readout. Then we have the quantum HPC schedule optimizer. Okay, ISA and microarchitecture, AI-enabled quantum compiler. Okay, quantum circuit layer and quantum algorithms layer. So That is actually a very nice picture, which also explains the whole quantum stack. So all the way from what we saw before with the nice blocks, which you basically drag and drop, all the way down to the quantum processor, where really like the system is at a cryogenic temperature and small currents are applied to manipulate the quantum state of your superconductor. So that's very interesting. Then let's see what we have here. QpiAI quantum QPU technology. So this is about the quantum processing unit. We see it's a superconducting system with CMOS-based and a roadmap to experiment with CMOS-based spin qubits. So they basically look into two different technologies. Superconducting, which is basically the one that IBM and, for example, Google are looking into right now, but then also moving towards spin qubits. So basically using single spins in a solid-state system, which can point up or down and manipulate those to actually encode quantum information. Okay. We see superconducting qubits right now. It's a NISQ system, so noisy intermediate scale qubits, which is basically what everything is right now. And then they want to move towards fault-tolerant quantum computing, I guess. Okay, here we can also see they use trans-1 qubits. So basically a qubit system which has a Josephson junction. I can also quickly show you here. Let's take a look at this. So basically it looks like this. You have a Josephson junction, you have a capacitor, and with those you are actually building your qubit. With those you're actually building your qubit. I think that one is a bit more precise. Yeah, but just know, I will do a specific video on those trans-1 qubits. Just know, trans-1 qubits, they are using a Josephson junction superconductor, and then you encode basically the state of your system in this phase that is being stored there. Okay, and then we see here the roadmap. So 2024 they had 25 qubits. 2026 it says 65 qubits. 2027 128, and then we have here Everest. So they also have nice names: Ganges, Everest, nature inspired in India, with 1000 NISQ qubits. So NISQ qubits are not error corrected qubits, as we saw here before, right? So it's these noisy intermediate scale quantum bits. Now I'm a bit confused because I thought we'd seen 125 already earlier with potential up to 300, and here it says now basically 2025 is somewhere between those two, right? Maybe I'm overseeing something though. Then we have the FTQC quantum computer roadmap. So this is fault-tolerant quantum computing, right? So there in 2026 we see one logical qubit. So important to know, these NISQ qubits, they basically have an inherent error probability. So things can happen that kind of shake your qubit a little bit and that influence the state. It could be that like there is a disturbing thing coming from the outside, but it could also be that there is a slight misalignment of the signal which is being applied that can all cause some types of errors and then propagate throughout your system. So this error is spreading because these qubits are also entangled, and that makes it incredibly difficult to actually remove those errors. And for this, you have a whole discipline of academic research, which is this FTQC, so fault-tolerant qubit error correction schemes. And this is what is being referred to here. So you take multiple of those qubits, you use the actual qubits and some ancillary qubits, and you basically hook them up together in a way where you can check if there's an error happening without actually reading the quantum information, because the things with quantum information, you cannot copy it. There's a so-called no cloning theorem. So you basically need to read whether there has an error occurred without reading the information. That's what makes it so challenging, and that's also why only one qubit is being formed out of a lot of actual physical qubits, and that's also why 100 qubits is only in 2030 here, where it says 2028 1000 NIS qubits, right? Okay, then let's move a little bit down here. We see the QpiAI's domain-targeted multi-agent system. So we see specialized agent clusters, quantum-enhanced processing layers, dynamic resource allocation, cross-domain knowledge integration. So now here, I guess we see the full scheme, like the zoom out of all the different components and things that are actually going into the system. I guess to go through this would be a whole crash course on quantum computing. And if you find it interesting, please let me know. I can definitely do that. We can walk through these steps. Maybe we can even get somebody from the company in to walk us through this. Just let me know down in the comments below. Let's go to the products real quick. Oh, okay. There's a lot of products here. Wow. Okay, I don't want to make it too long of a video, so let's just take the QpiAI Quantum and take a look at this one, and then we will wrap it up, I guess. So it says key functionalities, quantum compute access. Yeah, that's what we've seen before. Now it goes into more detail. Maybe we can actually look into one of these ones, which we haven't looked into the detail yet. So this is the QpiAI Matter. Yeah, and here we see now what the setup actually looks like. So we see the molecules, embedding methods, AI algorithms, hybrid QC algorithms, fault-tolerant quantum algorithms. Okay, and then, open source libraries integration. So software development kit, and then that basically explains, as it says, architecture and the pipeline. So this is very much the zoom out overview of how it actually goes, what are the components that are in the system, and probably also what you're working with. Here it says again those benchmarks that we saw before, so 1000 times speed up over DFT, 10 times faster discovery, that we already saw before. And then we can request access to basically try it out ourselves. Okay, very good. Solutions are what we saw probably before already. Resources, there's also an FAQ and they have a blog. Let's quickly check out the blog to see. Okay, we see there is some information, but it's not like they post on it on a daily basis. We all know it's not easy to keep a blog up and running. There are some FAQs here. What is QpiAI? Well, that's what we just figured out. How to get started. Okay, you can get started signing up on the platform. Wow, that's good. So I guess that was an interesting first glimpse at what QpiAI is actually doing. If you have some further questions, or if you like that format, if you don't like the format, if there is any company that you would like me to check out, let me please know below. That way we can create new videos for whatever you would like to see. Always make sure to stay hydrated, and see you in the next one. Bye.